On this worksheet, we're going to practice doing pH and pOH calculations. There's a couple different equations that we might end up using. I'm just going to write them all up here at the top to begin with. To calculate the pH, we can do that by taking the negative log of the H3O plus concentration. To calculate pOH, we could do that by taking the negative log of the OH minus concentration. And then last but not least, we have the relationship between pH and pOH. pH plus pOH is always going to be equal to 14. So we may use any of these equations on this worksheet. First thing that we're being asked to do is calculate the pH from the H3O plus concentration. So the fastest way, easiest way for us to do that is going to be to use pH equals negative log of H3O plus. And we're just going to plug in the value of H3O plus. 3.87 times 10 to the minus 9. This is definitely one that I want to use the calculator for. I can't do logs in my head. 3.87 times 10 to the minus 9. I'll take the log of that. And I'm getting a pH of negative log, 8.41. Is the solution acidic or basic? In problem number 1, an acidic solution is one that has a pH value that is something less than 7, and a basic solution is something that has a pH value of something greater than 7. And for chemists, this needs to be like spot on, right on the money. If it's 6.9, that is less than 7. That's an acidic solution. If it's 6.9999, that's less than 7. That's an acidic solution. In this case, our pH is 8.41, which is greater than 7, so that makes this a base. Next, we're being asked to calculate the pH of a solution from its OH minus concentration. There's a couple of different ways that we could approach this problem. There's another equation here I didn't even think about that we could use. So first of all, the pH calculation uses H3O plus, which is not the number that's been given to us. It is possible, if we want, to calculate the H3O plus concentration from the OH minus concentration using KW, which we practiced a couple days ago. So we could plug in OH minus. The value of KW is 1 times 10 to the minus 14. Maybe I'll just write that instead, 1 times 10 to the minus 14. And we could use this information to calculate H3O plus for this solution and then come up with the pH. That's not the method that I like to take, though. I think that takes a little bit too long. My preference is to calculate the pOH of the solution and then use pOH to come up with pH. And I don't really know why that's my personal preference, because I think they take the same amount of time. The pOH is the negative log of the OH minus concentration. The OH minus concentration is 1.4 times 10 to the minus 3. So the negative log of 1.4 times 10 to the minus 3 is 2.85. That again is the pOH. To get the pH, I'm going to use this equation right here. pH plus pOH equals 14. So the pH is 14 minus the pOH. 14 minus 2.85, which is going to be 11.15. Is this solution acidic or basic? Well, our pH worked out to be greater than 7, so this solution is also a base.